Today we're going to learn how to graph rational functions with slant asymptotes. So let's start off with this first problem. So our first step, like usual, is to factor. So the numerator, we can use the x. So what multiplies to give us 2, adds to give us 3, 2 and 1, and because there's no number in front of the x squared, we can just rewrite this as x plus 2, x plus 1. Our denominator doesn't change. So our domain, well, so first let's check here. Is there anything we can cancel out? No, we can't. This is a plus 1, this is a minus 1, so they can't cancel out because they're not the same thing. So our domain is just denominator doesn't equal 0, so we have x does not equal positive 1. Now, let's find our horizontal asymptote by dividing. So we're going to use our original x squared plus 3x plus 2 divided by x minus 1. So first term divided by first term, we're going to do x squared divided by x, which leaves us with 1x. We're going to put it on top. Multiply x times x gives me x squared, x times negative 1 gives me negative 1x. We're going to change the sign, so this becomes negative, this becomes positive, which gives us 3x plus 1x is 4x plus 2. We're going to again take the first term divided by the first term. So 4x divided by x, the x's cancel out, it leaves me with 4. So this is a plus 4 on top. So I have 4 times x is 4x, 4 times negative 1 is negative 4. Again, I'm going to change the sign, so negative, positive. This gives me 6. So now 6 divided by x I can't do anymore, so this is my remainder. So if I were to rewrite this using proper form, this is f of x equals my answer, which is x plus 4 plus 6 over my original function. So I know that my fraction goes to 0. So my end behavior is x plus 4. So before, up until this point, we knew that this was not a horizontal asymptote, but horizontal asymptote doesn't exist. But what this does give us is a slant asymptote. So for all functions where the degree of the numerator is 1 more than the degree of the denominator, so like this one, the degree x squared is 1 more than x, then we will have a linear slant asymptote, because this is a line right here that we find by using long division. So this is my slant asymptote right there, my answer. Let's see what this looks like on a graph. So, exact same problem we just factored out, but now we're going to go through all the steps to find my graph. So again, first step, factor. So my domain is x does not equal 1, because x minus 1 doesn't equal 0. And solve for x. There's nothing that cancels out, so this tells us that there aren't any holes in the graph. So if there aren't any holes, my vertical asymptote is x is equal to 1. So I'm going to draw that on my graph. For my horizontal asymptote, so this is what we just did. When we did our long division, it gave us x plus 4. This tells me that there is no horizontal asymptote because it leaves me with an x in my answer, but my slant asymptote is y equals x plus 4. So y equals x plus 4, if I'm graphing this, 4 is my y-intercept, 1, 2, 3, 4. 4 is my y-intercept, and my slope is 1. So it's really rise over run, which is 1 over 1. So my line is going to look like this. So my slant asymptote this time is going to be a diagonal line. So if y-intercept is 4, the slope is 1 over 1. So 1 over 1, 1 over 1, 1 over 1. So these are my two asymptotes. From here, everything else is the same, so we're going to do x-intercept numerator doesn't equal 0. My numerator, or does equal 0, excuse me. So my numerator is x plus 2, x plus 1, so I end up with x equals negative 2 and x equals negative 1. So my answers are negative 2 comma 0, negative 1 comma 0. I'm going to graph them. So negative 2 is right here, negative 1 is right here. My y-intercept, now I'm going to plug in 0 plus 2, 0 plus 1, 0 minus 1. This is going to give me 2 times 1 is 2 divided by negative 1. Gives me a slope of negative 2. So negative 2 is going to go right here. Okay. So just like before, we want to connect all of our points. And we're looking, this time, instead of going towards our horizontal asymptote, these are going to be approaching our slant asymptote. So in this case, these 3 points are going to be connected. And it's still going towards my asymptote in this direction. But this time it's going to be going towards this asymptote instead of my horizontal asymptote. So it's going to be a curve going in this direction and this direction. To figure out what's happening on the right side of 1, let's pick a number on the right of 1. So let's say 2. If we plugged in 2, this would give me 2 plus 2, 2 plus 1, 2 minus 1, which is a positive, positive, and a positive, which gives me positive divided by positive, which is positive. So I know this side above the 1 should be positive. So this time I want it to be above the slant asymptote. And so it's actually going to be up here, going towards both asymptotes. Okay, let's look at the next problem. Okay, so we're going to first start off by factoring. So the numerator here, x minus 1 to the third, just means that we have 3 x minus 1s. X squared minus 1, this is difference of squares. So difference of squares means that we have an x minus 1, x plus 1. So right away after this is factored, you should notice that there's something that can cancel out. So we have an x minus 1 and an x minus 1 that can cancel out. So for my domain, x cannot equal, so the domain includes both of them. So I have 1 and negative 1. But one of these numbers is our whole because they can be canceled out. So the one that can cancel out is this x minus 1, which gives us our root of positive 1. Remember, this is the one that x minus 1 equals 0. So this gives us positive 1. And to figure out what our y value is, we're just going to plug it back into our new equation. So our new equation is the one after we crossed it out. So it's now x minus 1 over x plus 1. So if I plug in 1, it's going to give me 1 minus 1, 1 minus 1, 1 plus 1, which is 0 times 0 divided by 2, which is just 0, because 0 divided by any number is 2. So my whole is at 1 comma 0. So this tells me my vertical asymptote doesn't include my whole, so I only have one vertical asymptote, and it's at negative 1. So I have a vertical asymptote at negative 1. I have a whole at 1 comma 0. Okay, horizontal asymptote. Now I'm going to need to divide to find my horizontal asymptote. So for this one, for me to be able to divide, I actually need to first multiply this out, right? Because I need it to be in polynomial form. So x minus 1, x minus 1, if I multiply this out, I'm using FOIL, or the box method. This gives me x squared, x times x, minus 1x plus 1. Combine like terms, this gives me x squared minus 2x plus 1 over x plus 1. Alright, so I'm going to multiply this out because now I can use long division to figure out my asymptote. Okay, so x squared divided by x equals x. Put it on top. X times x gives me x squared. X times 1 gives me positive 1x. I'm going to change the signs. So these cancel out. Negative 1 plus negative 2 gives me negative 3x. Bring down the 1. Next term, negative 3x divided by x gives me negative 3. That goes on top. Negative 3 times x is negative 3x. Negative 3 times 1 is a negative 3. Change both signs to give me a remainder of 4. So this is my answer right here, x minus 3. So because there's an x in it, that tells me there's no horizontal asymptote, but there's a slant asymptote of x minus 3. So x minus 3 has a y-intercept of negative 3. 1, 2, 3. Here's negative 3. And again, the slope is 1. So it's just 1 over, 1 up, 1 over, 1 up, 1 over, 1 up. So my line is going to look like this. That's my slant asymptote. Okay, x-intercept. X-intercept is looking for when the numerator, so x minus 1 equals 0. This gives me, if I solve for x, 1 comma 0, which we already know it's our whole, so we've already graphed that point. My y-intercept is what I'm going to plug in, 0. So 0 minus 1, 0 minus 1 over 0 plus 1. It's negative 1 times negative 1, which is 1 divided by 1. So this is also 1, 0 comma 1. And I'm going to plot this one. It's a y-intercept, so it's going to go right there. Okay, so for the sign analysis, these 2 points I know have to connect. This is going to go towards this asymptote. This one's going to go towards this asymptote. For the negative one, on the left side of negative 1, if I pick a number over here, so let's say negative 2. If I do negative 2 minus 1, negative 2 minus 1 over negative 2 plus 1, this is going to give me a negative, 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 which is a positive divided by a negative, which is a negative. So this whole thing is going to be underneath. And so I want it to be underneath my asymptotes. So this one's going to curve downward like this. So that is my function for number 2, or number 3.